Welcome back again, guys. So today we'll be looking at the logarithmic properties. So the first property that we'll be looking at is called the product. So the product it's actually defined to be the log of b multiplied by m, which is gonna be equals to the log of b m plus the log of b n. So what this property actually demonstrates or is showing is that if we have the multiplication of two constant, which is m and a, we can actually split them by addition, having the log of bm plus the log of bn. So let's do an example to understand this property quite well. So let's have the log of 3 9x. So as you can see here, we have the multiplication of two constant, which is 9 and x. So here we're going to have the log of 3 9 plus the log of 3x. So if you notice something here, our base doesn't change, so our base is common on both sides. The only thing that is different is actually splitting these two into two by a plus sign of logs. So if we have the log of bm divided by n, it's gonna be equals to the log of b m minus the log of b n. So here, this property, whenever we're dividing two, let's call them variables or constants, because this is the base and then these are your constants. So whenever you're dividing terms, what you need to do is just to separate them by a negative sign. So dividing, you separate them using a negative sign. But on the first example, or the first property, we had the property of product, which simply means here we are multiplying. So if we're multiplying here, we just separate the two by a positive sign. So that's what we have. So the second property, it's called the power property of logarithm. So it's defined to be log of b m to the power of p, hence the property name power. It has got something to do with a power. So changing this, or this property is defined to be, or to equate to p log b m. So what happened here is that we're actually multiplying the whole thing by the power of m, which is p. So let's look at an example to further explain this property. So here we're going to have log of 2 raised to the power, log of 2 multiplied by 8 to the power of x, and this, according to this property, is going to be equals to x being the power of 8, and then we multiply it by the whole stuff that's over there. So this is what going to have. So whenever you have your which is a to the power a, which is a to the power x, what you do is just to multiply the whole thing by the power. So that's what's happening here. Hence the property, it's called power. So the last property of logarithm here, it's called equality. So what this property actually says is that when we have the log of b m is equals to the log of b n, then m is equals to n. So if we have a log of b m which is equals to log of b n, then these two will be equal, given that we have the same basis right here. So let's look at an example just to further understand what's happening here. Let's have a log of 8 3x minus 4, which is equals to log of 8 5x plus 2. So using the definition of equality, as you can see here, when we have the same basis, we equate the just like here. We're going to say that then 3x minus 4 it's equals to 5x plus 2, according to the property. So there you have it, guys. So these are the properties of logarithm. So catch you in the next video.